We can give it a start. Welcome, everybody. My name is Ellie Shtereva, and I'm going to be your host for today's brief but very substantial session. We are starting with our first webinar out of a series of 5. Today's topic is the role of digitalization in advanced manufacturing. And as mentioned, this is part of a larger series. It is called Next Gen Materials Europe's Digital Manufacturing Leap. It is organized by 3 EU initiatives, DiMAT, metaFacturing, and Pioneer. And very important is that we're going to be focusing on the role of digitalization for manufacturing, why this is important, why the European Union is putting so much emphasis and support to the companies to be doing this shift in industrial digitalization. Here, for the different sessions, we have key experts from the 3 initiatives, just to let you know that all the 3 projects have been working for the past 3 years in this field, and each of them has an approximate number of more than 20 partners from different organizations with vast amount of expertise that is going to be shared with you. We hope that within the duration of 45 minutes for each of the sessions, we're going to provide you with as much as information to make you feel more comfortable and competent within this field. Why digitalization for manufacturing is important? Some of the benefits are, of course, very obvious. It is providing an unprecedented control over manufacturing in real time, also from distance, but also at the premises of a factory, for example. You can be controlling in real time the different functions, and also can be tackling errors that are coming in a fast and prompt manner. You can be also adjusting the different needs and parameters that you would need for the production of your end product. And when we're speaking specifically about material manufacturing, because all the 3 projects are dealing with this specific field, there are a lot of benefits and key performance indicators that can be improved when using digital solutions. For example, this can bring less trials and errors, meaning that you're going to be using less product, less material in your production. This is also going to support you when adopting different digital solutions for faster production and bringing your solution closer to the market at rapid scale. You can be also dealing with new material discovery. For example, even before you are actually producing the material, you can be testing the different parameters, for example, strength of your materials, and also see whether, for example, something else of a material that is more sustainable can be also used for the same purposes that you need it and your end users need it. Something that is also key is, of course, that the European Union is putting a great emphasis and investing in the digitalization of the industry within Europe. This is, of course, normal. The vision is simple: to make a more agile, efficient, and resilient European industry, not only within the European Union, but also to make companies more competitive in the international and global market. And when we go even on a lower level, speaking about SMEs, the challenge is, of course, more complicated, because smaller companies need more resources and access to digital solutions that, for example, larger companies have already adopted. And exactly here is where those 3 initiatives funded by the European Union have been working on very closely on developing the digital tools that are right for the companies in different sectors. And this is something that the presenters are also going to be speaking about. The solutions are more accessible, open, and user-friendly, exactly for the purposes of the companies to be able to support them and boost them in their progress towards digitalization and adopting digital solutions. As mentioned, the overarching title of our series is Next Gen Materials Europe Digital Manufacturing Leap, and I have just briefly discussed why this is important as a topic. And today we're going to do this setting the ground. So we're going to be speaking more about what is the role of digitalization in advanced manufacturing, the key challenges and trends, and main solutions that companies should be looking for. And then the next sessions are starting to delve into different but very important topics. So, for example, on the 27th of May, We're going to be speaking about standardization and data management for material manufacturing. And this is very important in terms of interoperability of the different solutions and the faster adoption from the companies. Also regarding data management, we're going to be speaking about the FAIR principle on how you can have easy and organized access to your data so your whole company can benefit out of this, regardless of whether you have your current employees or newer employees are coming. So the data is easily accessible and right where you need it. Then we're going to move on the 5th of June to digital tools for accelerated material discovery. And here we're going to be speaking about simulation of modeling and simulation, where you would be a company is able to be testing the materials of their production before it's even produced. And here you can see whether there are going to be any breakages, for example, how you can make your material more durable without this trial and error, wasting the materials and resources of your production, but doing it beforehand. And then on the 24th of June, we're going to be moving to circular materials and digital traceability. Here we're going to be speaking about life cycle assessment, also life cycle assessment, but user-friendly one, that you don't need that much of an expertise in order to be understanding the tools. And this is something that we're going to be speaking about within webinar 4. And then the final webinar is going to be focused on how digital twins and AI are revolutionizing manufacturing, which is also a very hot topic in the field. As mentioned, today we're going to be speaking about how digitalization is transforming the advanced material manufacturing sector. The session is going to be divided in 2 parts. The first part is going to be organized as a discussion. The speakers that we have today with us are going to share their inputs and feedback based on several key questions for the field that are going to be asked to them. And then in the second part, we're going to have some presentations coming from the 3 initiatives showcasing the digital tools that have been developed for the companies and what we have been doing for the past 3 years in order to support this process. As our speakers today, we have Nikos Kourkoulos, who is a project manager at CERTH and also the project coordinator of DiMAT. We have Manfredi Pistone, who is technical manager at ENG and also representative of the Pioneer project. And also we have Vitronic, who is a product manager at Vitronic, who is also representative of the project metaFacturing. All of the speakers are also going to give us some hints of the overall initiatives that they're part of, and then they're going to delve into their specific topics. Now, before we delve into the discussion, I just want to mention for all our audiences, in case you have any questions, you can be asking them at any point. There is a Q&A chat box that you should be able to see on your screens. You just type in your question, and then I'm going to be directing it to the most rightful speaker for it. Okay, and now moving to the discussion. I have prepared several questions for all of you, and let's start with the first one, which is why is digitalization becoming crucial for competitiveness and innovation overall, and how does this affect manufacturing SMEs? And we can start first with Nikos.
Hello, good morning. I'm Nikos Kourkoulos from CERTH, and for this topic, I think that digitalization is becoming a foundation for competitiveness and resilience in manufacturing. As global supply chains become more dynamic and customer demands shift towards customization, quality, and sustainability, only the digitally enabled manufacturers can keep up. The real digital transformation will only succeed if SMEs can also participate in this. SMEs represent a major percentage of manufacturing firms in Europe. They are essential to industrial supply chains, but many lack the resources or internal expertise to implement complex digital solutions. Digitalization helps SMEs work smarter. It allows them to access and analyze data that they already generate, but often they do not use. They allows them to improve quality and productivity through process monitoring and simulation, and reduce waste and energy costs, improving sustainability compliance. also to collaborate across value chain using common digital standards. And tools for this purpose must be affordable, in my opinion, and modular and easy to adopt. That's why projects like DiMAT, metaFacturing, and Pioneer are so important to this. We are not just developing technology, but we are helping SMEs join the digitalization era without being left behind.
Nice, thank you, Nikos. And then maybe moving to Peter, can you tell us how is this relevant to advanced manufacturing specifically, and what actually do we mean by advanced manufacturing?
Yes, good. Hello, everybody. Good question. So what is advanced manufacturing? So we are coming, or also in the metaFacturing project, we are in highly active and highly automated manufacturing. Yeah, so we have partners like Benteler in there, and they produce battery trays in high volumes. And so this digitalization is especially relevant for high volume production. Yeah, for example, especially this is in the automotive industry. You have this, but you have also, of course, small and medium-sized companies as suppliers for the automotive industry who also produce in high numbers. And there is a constant need for higher efficiency. I think especially in the momentary discussion, you have this about the competitiveness of the German automobile industry, but probably also the European automobile industry. So I think I don't need to detail this. So yesterday I read something that even good people nowadays in Germany, they don't get a job because of cost cutting. And so cost cutting is very important. And so how can you reduce costs? Prices are already quite high, so you need to improve to make the production more efficient to cut costs. How can I make the production more efficient? And in this case, you need to know also that maybe we are not talking about 50%, for example, increase in effectiveness. Even 5% only in increase in effectiveness is a huge success. Yeah, in case this is done in the automobile industry, that's a big success. So we are not talking about this only small increases, and there is a big contribution, I think, about digitalization for this goal.
Thank you, Peter. And then building on top of this, can we maybe discuss on what are the actually current challenges in front of SMEs when adopting and even having access to digital solutions? Manfredi, if you can take this one.
Yeah, thanks, Ellie. Hi, good morning, everyone. So this is an interesting question that we could discuss for the whole day, but I'll try to summarize it as much as I can. So I would say that the first challenge is the poor small medium enterprises involvement. This is often due to factors like limited access to finance, complex regulations, or insufficient and inadequate skills and training. Moreover, another issue, another challenge that usually SMEs have to face is regarding the security concerns. So most of the time, let's say enterprises don't want to disclose their data outside of their premises. This, let's say, transform into the lack of digital continuity because you can trace the data from the start to the end. And of course, this is one of the major issues that, let's say, limitate the feasibility of the enterprises to reach the zero defect manufacturing. Because to have zero defect manufacturing, you need to have an holistic approach to the data. And to do that, of course, you need to, let's say, monitor in real time from the start to the end. The problem, to tell the truth, is that the zero defect manufacturing today is still perceived as a cost rather than an investment. And for this reason, most of the time, for example, the quality control is performed just at the end of the processing lines and not across the whole manufacturing process. So this makes literally impossible to react once the defect is detected.
I think you have touched upon some very key aspects, and I'm very glad that we have also pinpointed exactly those topics in our follow-up sessions. As I've mentioned, the second one is going to be exactly on data management, which is one of the challenges that you have mentioned, but also with the digital twins, we're going to be discussing this aspect of how to be tracing and also be monitoring the production lines. Okay, and then I have this final question, which is actually to all of you. So if you can provide one or two sentences and inputs as closing for this first part. And this is what are the current trends and solutions that SMEs can look towards to? And maybe something that is very important, what is a must as a digital solution for them to be already having and adopting from this point forward to be as competitive and able on the international market.
Can I start? Okay, I see that digital solution that is increasingly necessary nowadays, especially from the European Commission, is the digital product passports. That are passports for products or machinery for compliance, sustainability, and circularity. And the second thing that I see that's AI enhanced quality control, like vision systems and machine learning models that can detect defects or process deviation in real time. That's I think the two hot topics that are nowadays.
Maybe I can continue there. It's of course, you mentioned AI. That's of course, it's a big trend currently, which we also observe. But in order to use AI, you need some automated kind of inspection and or automated process control somehow. So, but first thing is of course, so we need to be competitive. So and that's of course be innovative, produce with highest efficiency and highest quality. How can we do this? Big help is digitalization. Yeah, first, I think to achieve transparency of the production. So in case you don't have these data, you don't know what's going on in the production. And so first, only when you collect all these data, then you see, okay, you have a transparency. You can also document everything for tracking, especially important for the automotive industry. And then you find optimization potential. And I think the first step, so what is the need is really to do this, is you need what we often find, parts are not coded. So you need a code of each part in order to connect all these data. So this is not yet implemented everywhere. So, but this is then the first start. So you need to code the parts and then you can link the data. And of course, when you produce, so this is all this digitalization is not for free. It costs, and it makes, in my opinion, also, or especially what I'm talking about later, the automated well seam inspection. Yeah, this makes only sense in case you produce really in high numbers, because you need a robot, you need all this setup and so on. So it's about, I'm talking about you produce 10,000 parts or more per year. Yeah, and then it makes really sense. Then think about automation, automated inspection, and yeah, and what you can also, so in case you are interested, especially in weld seam inspection and process monitoring, then join our webinar on 4th of June. So this is also what you can do. This is a get more yield with Smart Arc Vision. Yes, so I can put it in the chat, so a link so that you can have there more information on this.
So to add my 2 cents on what the guys said, Peter and Nikos, so they touched 2 important topics in the manufacturing domain, which is the AI and the quality inspection control. But I think it's worth saying that you can do any of these things if you don't record your data, if you don't store the real-time data that occurs along the processing line. I love to say that you can't improve what you can't or you don't measure. So in this sense, real-time monitoring and also enabling the industrial IoT is one of the most important things that small, medium enterprises should achieve.
Absolutely. Very important points. Something that we can share also from our experience in DiMAT, we had this collaboration with early adopters where they were testing our solutions. We were asking them exactly, small and medium companies, we were asking them what are their current processes. And it really turned out that most of them, regarding data management specifically, they either still use paper-based description of their data, so they do it on actual paper or Excel sheets, so nothing is automated, they don't have this process flow. So it turned out that it's key for them to understand what is the technology out there and to support with this further. And also regarding the digital passports, I'm going to promote another EU initiative, but I think this is why we're here for. It is called CERTH, and they have all the data needed for the digital passport for you to get acquainted in case you are unaware yet, or in case you want to delve deeper into this topic. There is one spot where you can get all of this information. It's called CERTH. Okay. So I see that there are, Peter has put the information for the webinar. Thank you, very fast and efficient. So yes, please do not miss this webinar. It's on the 4th of June. Okay, so then I think we can move ahead with the actual presentations of what has been developed up until now and what is out there coming from the three initiatives, DiMAT, metaFacturing, and Pioneer. We will start first with DiMAT and Nikos' presentation. So Nikos, the floor is all yours.
Thank you. I will present you the overview of the DiMAT project and how we contribute in digitalization of advanced manufacturing. The DiMAT project is focused on the development of digital technologies for modeling, simulation, and optimization in each stage of the material value chain. Previous slide, Ellie, please. Okay, so what are the major challenges in the advanced manufacturing sector? There is no common framework for linking process data, material behavior, and product performance. It is really difficult for SMEs to model, simulate, or trace advanced material across their life cycle. The high cost of digital tools and the lack of expertise act as barriers to enter this digitalization era. Next slide, please. In order to help SMEs in their digitalization journey via cost-efficient and targeted solutions throughout the different phases of the material value chain, we develop open digital solutions for modeling, simulation, and optimization in each stage of the material value chain. For this purpose, we are developing 3 suites. The Data and Assessment Suite, which is focused on digital technologies for storing, sharing, and assessing materials data. The Modeling and the Design Suite, that is focused on material design, predicting material behavior before manufacturing. And the third, the Simulation and Optimization Suite, that is focused on materials manufacturing, simulation, and behavior prediction. These suites work together to help SMEs design, test, and manufacture advanced materials digitally, improving quality, sustainability, and competitiveness. Next slide, please. Okay, to give you an overview of each suite, includes 3 toolkits. The Data and Assessment Suite consists of the Cloud Material Database Toolkit, which is used for storing data in a harmonized way, the Knowledge Acquisition Framework that classifies materials in a graph, and the Materials Environmental and Cost Life Cycle Assessment Toolkit that gives a graphical estimation of the environmental and economic impact. This suite uses semantic technologies to organize and connect materials data. It stores and shares materials data, acquires new knowledge from existing datasets, and assesses material options based on environmental and economic impact. As a result, empowers SMEs to make sustainable, cost-efficient choices at the design phase. Next slide, please. The Modeling the Design Suite includes the Material Design Framework Toolkit that provides info for the material design processes, the Materials Modeler that assists in designing materials predicting their behavior, and the Materials Designer assisting in the design of complex materials. The suite is a set of digital tools that allows users to design materials based on interval structure and performance outcomes. It helps shorten development cycles, avoid costly physical tests, and optimize materials early in the process. SMEs can design materials tailored to their desired properties, reduce development time and costs, and compete in innovation-driven sectors. The suite makes advanced materials design accessible to SMEs without in-house labs or simulation experts. Next slide, please. Okay, the simulation and optimization suite that includes the materials mechanical properties simulation that predicts mechanical behavior, the materials processing simulator that predicts the outcome of materials processes, and the third one, the digital twin for process control that develops digital twins for enhancing industrial business process control. Through this suite, digital simulation of the full manufacturing process are created, helping in determining best processing conditions from different materials, and then predicting how these materials will behave in real-world problems. This suite enables more efficient, error-free production, critical for small companies that managing complex materials with limited resources. All suites and toolkits are interconnected and can be provided as a holistic solutions. Next slide, please. Through our development of our solutions, we have three main goals. As technological, we help speeding up digital tech adoption in materials design and manufacturing. As economic, we provide affordable tools for SMEs to innovate and compete globally, promoting the transition to industrial digitalization. And as societal, our goal is to speed up the transition to a greener economy and support the sustainable goals of SMEs. And that was all from me. Thank you very much for your attention. We can move on.
Sorry, thank you, Nikos. Then let's move to the next one. Okay, and this is Peter with his presentation from Vitronic. Let me just stop sharing my screen, as I know that Peter would like to have control over his presentation.
Okay. So now you should see my screen, yes?
Yes, perfectly.
Okay, thank you. Okay, then, so first, the introduction of metaFacturing. So metaFacturing is actually, so it's a abbreviation of data and metadata for advanced digitalization of manufacturing industrial lines. And as I said before, so we are here mainly in the automotive industry active. So in Europe, we have about 14.8 million vehicles produced annually. We said there's a constant need for cost cutting. And so in metaFacturing, we are focusing on the digitized tool chain for metal part production, and targeted is a more resilient production process with respect to raw materials. So there's a link also, of course, to DiMAT and Pioneer, and also reduced operator effort and cost and reduced scrap due to out of specification. So partners in this project are Benteler Nemak from the automotive industry. Then we have research institutes and also so RISC, AIT. We have casting use case in there. So I'm here from the welding use case. So the casting is LTH. Phil as a machine builder, we have the material specialist, and also for simulations, KU Leuven, Ghent University, and the European Welding Institute, EWF, and also from Portugal, ISQ, and of course Fronius as the weld system, big manufacturer of welding systems. So all there's really all the and Vitronic, I didn't mention, of course, as a specialist in inspection. So you have all the specialists from the different fields in this project. So how do we optimize welding processes nowadays? So it's you weld, then you do so in case of weld seam inspection, yeah, in case it's an automated line, then you have data from the inspection, and then you find, okay, there are defects, and then you do a manual analysis. Now, where are these defects coming from? So how can I stop these defects? And then you often but this is a manual kind of process. Then you find a defect. Often it's like this. Oh no, this defect stopped. Oh, I'm happy. And then, but you didn't know exactly where it was coming from. And then the cycle starts again. So what we want to do is to make this a bit more effective. And so what you observe currently is, so you have the manufacturing process, and then you have 3 different quality cycles in the industry. So one quality cycle is you monitor the process data. Then you have an inline inspection, and then you have also a destructive test. But all these data are currently not yet really fuse together. And this is, of course, one thing that we want to eliminate here, these barriers, and fuse these data together. And of course, in the project, we also work about material identification and so on, and then feedback processes. What I'm currently focusing here is this data fusion, and so that we have here really some benefit out of this data fusion, and so that we can reduce this scrap. Of course, when you have destructive tests, it's a lot of scrap, which you want to reduce. This is a huge cost. So the first step is that we combine the process data from the welding line with the inspection data. But this is not so easy, because normally you have several welding robots welding a part, and then you have one inspection system inspecting the part. Moreover, you have here a time-based, so the process data, it's a time-based signal. And in the inspection, we have a position-based. So we have the weld seam on a position, you have a position-based data. And so what we do is now these data are here combined in the Fronius WeldCube Premium data server. Then the part comes to the inspection, and we grab the process data from the welding and combine this, map this to the position-based data in the from the inspection. So this looks like this. Then in the software, you have here the 3D picture of the part, and then below, normally you would have here the throat thickness and so on displayed in the cross section of the software. But here now, instead of this, you see, for example, the voltage, current, wire feed, and so on, so that you really can look, okay, what's going on? Where is my defect here? And so this looks like this. So this is set up at the Fronius headquarter in the lab, but it looks, of course, very similar than in the production at Benteler. I hope not. We don't produce these defects. So in here you see the so first the welding, then the inspection. There is a defect, and now where is this defect coming from? And now you go into the software. You see directly below the inspection data. You see the voltage, the current and voltage. You see all these process data. And now you have to imagine you have about 30 welding systems in a line, and now you detect this defect. From which welding system is this defect coming from? And now within the inspection software, you directly start here this WeldCube Premium software. And so you directly jump for this weld seam, you jump into the data in the production data of this weld seam, and you can here then change or look for more information, or even change then the limits, for example. So what is the goal is, of course, first we did this, we have improved analysis for structured and more and faster optimization. The next thing is that we feedback. So the welding process is kind of blind. It does not see the result. So we feedback the inspection data back to the welding process. So this is, we call it weld loop then. So that here also this, the welding systems is learning. This is of course still research going on. But then we, in addition, as I said, we combine this process data and the inspection data also with microcut data, so that we also can predict the penetration, for example, here of this in this welding, and can reduce so we can reduce the destructive testing, produce less scrap. Of course, we improve the output, so we have more okay part and less reworks, so that we can improve the efficiency of the whole process. So that's yeah. Thank you. That's my presentation.
Thank you, Peter. I think it was very, very interesting. Can you tell me when potentially is this solution going to be available for end users?
Actually, so what I showed you in the video, that's already available. So this is an existing solution. With the penetration, this is currently in development, and will show a preview at the own metaFacturing booth at the Welding and Cutting. This is in September this year in Essen. Yeah, that's the leading fair for welding. And there we have an own booth of all partners from the metaFacturing, where we show the results of the project.
Great.
And hopefully then more products will be available next year.
Excellent. Thank you for sharing. And for everybody who would like to meet the metaFacturing consortium, you can meet them in Essen at the event in their designated booth. And also you saw Peter's contact. So in case you would like to contact him further, I will be also sharing after the end of this webinar, the slides and also further information for the follow-up webinars coming, so you can directly ask me in case you would like to have the contacts of our speakers to discuss further opportunities with them. And now I am moving to the final presentation. Just give me a second. And this is going to be presented by Manfredi Pistone.
Thank you, Ellie. Okay, so next, please. Today we live in, let's say, this turbulent market where there is an increasing demand for, let's say, product variants, but coming in smaller lot sizes. So this, of course, increases the worldwide competition and also the pressure on the production costs for the entrepreneurs. So here, especially with Pioneer, we have identified 4 main challenges that we tried to face and let's say to win. So first of all, there is the shortened product life cycles, which is a trend also known as the collapse of life cycles, in which basically the product and the services are replaced so fast that the companies can keep up with the, let's say, product innovation and also the time to market. So another challenge is indeed the high mix and the low volume production schemes, which is exactly just what I was talking 1 minute ago. So let's say this production scheme require modular production solutions to keep up with the production costs. Then another challenges is the end-to-end knowledge of the material value chain. So this means understanding the whole process from the sourcing of raw materials to delivering the final product to the customer, and even after sale, also, let's say, keep up with the assistance and the customer service for the final user. So this is an holistic approach that emphasizes the integration and the optimization across the all stages of the supply chain. And this is something that we particularly addressed within the Pioneer project. Finally, the last challenge is the zero defect manufacturing, which is exactly what I was talking before during the question sessions. So zero defect manufacturing, let's say, is this strategy, this need to achieve the zero defect production by the means of the quality inspection control across the whole production line, and not only doing the quality assessment of the product. Next, please. So in particular, focusing on the 3 core pillars that you see on the right, so the materials, the modeling, and the manufacturing. The Pioneer's vision was to, let's say, provide innovation by addressing a design by simulation optimization framework, and also by providing the end-to-end data flow along the whole product life cycle or the material value chain. Next, please. In particular, we, let's say, studied 2 main use cases. So the first one was the wire arc additive manufacturing by MX3D, and the second one was the sheet molding compression by Marelli. So the main goal for the former was to, let's say, create a novel and highly optimized structural element manufacturing using the indeed wire arc additive manufacturing. But an important point was to ensure that we also achieved, let's say, certified printing strategies. So this was done by enabling that exchange across the whole material and value chain. And also, let's say, through the hybrid manufacturing, we were able to increase the performances of the whole production scheme. For the latter, on the other hand, the goal was to optimize the product design and the structural behavior of the carbon fiber sheet molding compressed materials using in particular simulation tools. So once again, this was achieved thanks to the real monitoring and the control, which was enriched by the real-time data-driven optimization strategies performed by the ROM, the reduced order model. Next, please. Here we have, let's say, a wider look about the features that we implemented inside the Open Innovation Platform. So in particular, we have this, let's say, virtual engineering workflow assisted by the digital twins and the data-driven models that in the end, let us achieve this representation of the whole material value chain. In the end, of course, we got the semantics and the interoperability that, of course, enable this communication across the different layers of the architecture. So thanks to these features, we could say that the Open Innovation Platform was able to support the design by simulation framework. And this means that before every new part is made, the process was already optimized in a virtualized environment. Next, please. So here we can have a look at the reference architecture that we developed for the project. So as you can see, it is based on REMI 4.0, and you can see the different horizontal layers from the field to the enterprise. In particular, what's worth saying about this architecture is that it's a service-oriented architecture. Let's say this feature is enriched by the software as a service methodology that we kept in mind while we were developing this platform. Another thing which is really important to say, if you can see on the right, is this interconnection with the Digital Agora, which is essentially a marketplace that provides knowledge, skills, and assets as a result for the outcomes of this project. Next, please. Okay, so within this context, so I'm referring to the Digital Agora being the marketplace for the project. What we also achieved was a kind of flexibility that it's really, let's say, innovative and not trivial at all for the manufacturing domain. So in particular, the Digital Agora was able to serve, let's say, as a setup process for the Open Innovation Platform. And by the means of a ready-to-deploy configuration file, you were able to decide which kind of deployment scenarios you need for the Open Innovation Platform installation in your premise. So in particular, depending on your infrastructure, you could choose between having a full-edge Open Innovation Platform, a full cloud Open Innovation Platform, or a hybrid version, in which maybe you could, let's say, exploit the capability and the power of HPC infrastructures in the cloud to train your AI models, and then use your models on your data on your premise. Next, please. So finally here, we talk about two of the main components that give the Open Innovation Platform its strengths, I would say, which are the digital pipeline and the digital thread. So the digital thread actually provides this end-to-end connection of data across the whole product life cycle So from design to engineering to the manufacturing and finally the quality control, which is really crucial in this project because, as you know, the value chain generates a vast amount of data, and the digital thread is exactly what's needed to exploit this data. So enable the small medium enterprises to harness this data and achieve real-time decision-making, enhanced traceability, and also predictive analytics. Within this context, the Open Innovation Platform as a whole represents the backbone for the, let's say, digital pipeline, because it enables this exchange of data, which is heterogeneous, of course, across the entire product lifecycle. Next, please. So finally, here we see, let's say, the results, the outcomes of the project, of the OEP, generally speaking, which is this workflow editor that you can access through the digital thread. And it lets you, let's say, manage the whole material value chain. So from the sourcing to the quality inspection after the production process. Which is really, let's say, convenient for the final user because you got everything you need in a single dashboard. So that's it from my side. Thank you.
Okay, thank you, Manfredi, for this presentation. Just a quick question on my side. So from what I understood, if a user goes to the Digital Agora, to the marketplace, they can access the platform. Can they download it, or is it a cloud-based, and do they have free access, or they need to purchase it? And is it available now, or it's going to be available in the near future?
So we're still working on this, and it's going to be available in the near future. And yes, exactly as you said, so going to the Digital Agora, you will be able to, let's say, customize the deployment scenario you need for the Open Innovation Platform, which not only means deciding if you want the Open Innovation Platform on cloud or on edge, but you will also be able to pick the components, the modules that you need for your application.
Okay, thank you so much. Well, this was our final presentation for today. I think we received some excellent inputs and knowledge from our three speakers. For next time, our next webinar is going to be on the 27th of May. We're going to be focusing on standardization and data management, and there is a lot of hot topics within this field. Please prepare your questions up front so you can put them in our chat box and you can address the speakers. Those webinars are also developed for companies that have initial access to digital solutions or are about to be exploring those opportunities to get more information. So we're trying to make it as easy to access as possible. So please use our speakers while they're here so you can ask them as many questions as possible. Final thing before we close, on the 18th of June, DiMAT is going to be in Valencia. We are going to be having a workshop starting at 6 o'clock. It is going to be hosted in the Polytechnical University of Valencia. Nikos, am I saying this right? We are going to be in the premises of UPV,
Yes,
right?
yes, right.
Okay. And so we're going to have a 1-hour workshop specifically designated for SMEs. And at the end, we're going to have a networking cocktail session. So if you're a Spanish SME and you're located in Valencia or close by, please come. You just need to register. We have this registration open on our F6S page, and you can find also more information on our LinkedIn page and on our website. But please do not hesitate to join. It is going to be very interesting. You're going to have demo sessions of our solutions, and you can explore further collaboration with our larger consortium. So with that said, I can close officially our first webinar. Thank you for your attendance and see you on the 27th of May. Bye.
Yep. Thank you.
Thank you.
Ellie.
Bye.
Thank you, everybody.
Thank you.
Bye-bye.
Bye.